Okay, so today, this is section 11.2, the second day of Mountain Notes. First thing we're going to be talking about, if you look in your packet, first thing you're going to want to know is stress. Stress is the measure of the amount of force applied to a given area. Biggest way to think about this is if you think of the weight of the world is on your shoulders, you should start feeling some stress around your shoulders. Okay, if you get a little more tension, think of the pressure that's kind of right around your neck. It would be the measurement of force right around your neck. So if you're stressing out a lot, you're going to have more force or more pain right around your neck. Less stress, less force. Okay? Okay, stress applied to rock causes it to either break or be really brittle, or the second one is going to be to bend or be ductile. The biggest thing with this is to break or be brittle is going to happen close to the surface of the earth. So, first mile or two. Okay. Think of it as a lasagna noodle or a whole bunch of spaghetti noodles. Okay. If I try to apply force on both ends, they're going to give a little, but then they're going to snap. Okay. If I put those noodles in some water and bring it up to a boil, what's going to start happening? They're going to start bending a little. They become a little more ductile, okay, and flexible, okay. And if I really get them fully cooked, okay, really past al dente, they're going to be bending all over the place. So be folding on top of each other, left and right, okay.
When stress causes the rock to bend, that's deep down in the earth.
Okay. So yeah, also remember that when it's really, really bending, that's going to be near the core or those layers that are farther down
where the heat of the earth can...
The heat of the earth is really hot. Okay, we're talking a couple thousand degrees. Okay, moving on. Okay, so we have our three different types of stress. Compression is going to be squeezing together. Okay, so think about this as... let's see. Compression. I basically got my towel here. Okay. I've got my second towel over here. And I'm putting them together. Okay. And I push together, and boom, I start getting folding. Okay.
And he's squeezing inward, which is causing the towels to fold up.
Yep, squeezing inward causes the towels to fold. Tension is going to be pulling away. Okay, so start off like this, and
opposite directions.
Opposite directions. Okay. Another one to think about is Laffy Taffy. Basically, you start off like this, and I start pulling, and it's going to stretch and get brittle in the middle or smaller in the middle. And finally, shear stress is basically pushing in opposite directions. Okay, so going left, right,
up, down.
Up, down. Okay.
Those are your three types of stress.
Those are our three types of stress.
Okay, so we've already discussed what stress is defined as.
Okay, stress is defined as the type of stress, and we have those three types, correct?
Yes.
Okay. At this Earth's surface, remember where it's going to be fairly cool, 60, 70 degrees, or it might be a couple hundred degrees just below the surface, a mile or two, but nothing too extreme. An example would be like a diamond mine. The deepest diamond mine in South Africa is about a mile down. When workers are working down there, it is about 100, 120 degrees all the way straight down in the mine. Okay. Okay. So at the Earth's surface, stuff again is kind of like that noodle. It's going to be brittle, rigid. Rocks break. You're going to have fractures, so those small little hairlines. Okay. Cracks, faults. Okay, so if you start thinking California, where we saw that one picture of a different field and there was a crack going down, that was the fault. Okay, deep below the Earth's surface, you're going to have the higher temperature. Remember, farther you go down, the higher the temperature goes up. Rock is going to be ductile, which basically means it bends, folds, stretches. That's going to be the different thing that you could do. Okay. Okay, so. Want to talk?
Compression is when you've got like your two bulldozers here and you're pushing together.
Okay, so The compression, as we just said, is basically two things pushing together. So here we have the two bulldozers, one on the left, one on the right. They're kind of applying force in the middle of that shortening example, and you start to see the
you're either going to see folding.
Folding right here. You see that example? Okay, so the example would be this folding, where we get going up and down.
It's going to be the fracture.
Or you're going to get that lovely fracture, which is right here, and you basically see the line right here. One part is going up, and the other one is going down. Okay? What's our next type? Oh, stress. Stretching. Okay, so here we have our lovely example in the middle. Okay, and we once again have the bulldozer on the right and on the left, and it's kind of like a tug of war, correct? Okay, we got bulldozer A here, and it's pulling to the right. Over here we have bulldozer B pulling to the left. Which one is going to win? Okay, something's got to give in the middle. Okay, so looking at this example right here, we see they're pulling to the left, pulling to the right. Okay, this one's pulling this way, this one's pulling this way, like that lovely thing, like a lovely battle of tug of rope. Something's got to give in the middle. Okay, that middle soil is starting to give. It's starting to thin out. If not, we're going to start seeing that stress factor right here. Again, something's going to go down, something might go up. Okay, and right down here we have shearing. Okay, so this is going to be kind of like the towel that we just had up here. We have the bulldozer right over here. It's pushing inward, and bulldozer B is pushing inward. Okay, so something's got to give. Pushing force here, pushing here, kind of like that big piece of white foam. We get the twisting. Okay, and you can kind of see down here the strike. This would be an example of the strike slip fault. Let's see if we. Okay, now we have an example of a strike slip fault. So I'm trying to do this one right down here. Okay, so you got our two pieces of land. So think of this as the Pacific Ocean. Think of this one as a North American plate. Okay, they're kind of coming up against each other. Okay, one is slipping past the other. Now remember, we just talked about this back with the earthquake unit. Friction holds them together. Okay. So they keep on going like this. The tension is building up. Okay. Eventually, one plate overcomes the other one, and what happens? We have an earthquake, and that's basically when it slips into its next point, and you get that jerking motion. The more pressure that builds up, and then once it overcomes the friction, the bigger the magnitude or the more energy is released in that earthquake. Okay, so now we are back. Now we are going to be talking about the different types of stress that form different mountains. Okay, so looking at these different types of pictures, we are going to be trying to identify what type of stress causes. Okay, so what type of structure is formed? And is this due to brittle or ductile deformation? Did it form at the surface or did it occur deep below? Okay, so let's look at this picture. Okay, so we kind of got this wavy action going on right here. You can kind of see with the mouse going on and my lovely meter stick. So we're kind of going down, and then we're going back up, and then we come down. Okay, so does it look like anything really broke, snapped? Okay, I don't see any examples of faults, any fissures, any lines around here, right? Okay, so what's the next thing we got to consider?
So we need to figure out the type of stress, so it would be compression.
Compression, right? Because we started applying a heat right down here, and the stuff started bending, right? Up and down.
Think of the towel as we folded it together.
Yep, the towel folding together, kind of coming. Okay, let's do. Okay, we are back. Now, Miss Hardy is going to give us an example of compression. She's got this lovely athletic towel right here, lovely green, and as she applies pressure on the right and left side, see it begins to fold and come on top of each other. Okay. Does that towel look very similar to our lovely picture right over here? Yes, it does. And our different examples of the different layers of the towel, as you can kind of see, You got 1 layer, 2 layer, 3 little, 4 little layers, 5, 6, 7, 8 little layers, 9, 10, 12 different types of layers, all for the different types of layers. Okay, and that goes back. Thank you very, very much. Okay, so getting back to the point, let's look at the different layers. Did it form at the surface or deep below?
Deep below, Mr. Franta.
Deep below, Mr. Franta, and that is awesome.